Hello students, welcome to Computer Networks Lab. So in this session, we'll see one of the lab experiment from Computer Networks Lab. Okay, um, this actually has got two parts, part A and part B. Part A, which contains the simulation part, and this is the part B actually, the programming part. All the programs to be implemented using Java. Just recall your algorithms lab, where algorithms as well as the data structures lab, where you have used Fedora or Linux environment, right? Uh, so the same environment, programming environment is used, or IDE is used for execution of these programs. So just recall how to compile and execute the Java program. So program name should be terminated with Java, right? The file name should be uh, class name where exactly the main function is included. So class name followed by dot followed by Java should be the extension. And compilation step, just recall Java C followed by space followed by filename.java, right? This is what compilation step. And to check the output, you have to execute the bytecode. So Java followed by space followed by file name. You should not use any kind of extensions and all. So this is what the steps you have already studied about this in the previous semester. Just recall, right? Okay. So we'll begin with one experiment. Write a program for congestion control using leaky bucket algorithm. So what is congestion and how to control it? This is what you need to glance about, you need to study about. Anyhow, this is there as the theory part. This is there at computer networks theory, I think fourth or fifth module. Okay, we'll see the diagram once. Just hold on. So leaky bucket algorithm is one of the congestion control algorithm. It is used for traffic shaping. So we can send the packets in a constant rate. We can, if you want to send the packet in a constant rate over a network, then you can go for this algorithm. Um, so this also avoids the congestion, or it controls the congestion, you can say, one of the congestion control algorithm. So here you need to define the bucket size and packet rate. What is bucket size? Bucket size is the capacity. Okay, it is something like, say, this is what a bucket is. So the base of the bucket, let this is the base of the bucket, and it has got a small hole. Okay, this has got a small hole. So let me, yeah, this is what a bucket is, and the bucket has got a small hole at the base. So whatever the input data rate may be, but what happens, say input rate can be anything, but the output flow will be constant, right? Output flow will be constant. Just imagine there is a bucket, and the base of the bucket has got a small hole, or it has got a tap. Even though the bucket is full and the input rate for the bucket is maximum, there are two, three, multiple taps are given for the for filling up of the bucket, but still the output will flow in with a constant rate, right? This is the basic idea behind this algorithm. Okay, please try to understand. Very simple thing. See, capacity of the bucket is also matters. Once the capacity of the bucket exceeds, then you cannot uh, insert the packet, data packets onto it. It overflows, right? That condition to be monitored. Once the bucket, here in terms of data we are speaking, once the defined bucket size is by size reached the maximum value, we have to ignore the remaining packets, in the sense bucket overflow should be displayed, or that is to be monitored. Okay, and packet size and output rate also matters. See, output rate is considered in terms of uh, kbps or mbps or bps, right, per unit time, whatever the unit it can be. It can be a byte or bit, or it can be word, whatever the unit you take. So now we have taken here bytes, so many bytes per second, say 10 bytes per second or 20 bytes per second. That is what the output rate we are going to fix. So packet size is also compared with output rate. If the packet size we have defined is 20 MB and the output rate is 10 MB, then what will happen? Entire 20 MB of the packet cannot be sent at a time. Only since you have, now I am considering the unit in terms of MB, so let it be whatever the unit it is. So output rate we have defined as 10 MB. So 20 MB packet should be divided into 10 into 2, that is 10 and 10 MB. First 10 MB will be sent, remaining 10 MB will be sent in the next fraction of second or next interval, you say. Getting no? So this is what the basic idea behind the algorithm, leaky bucket algorithm. Let us see how to implement this. Uh, Very small program. Okay. Here first two statements, the import statement, recall the import statements are required, java.io as well as java.utility.scanner. This is this we have imported since we are using different functions from it. Like from scanner class, obviously the input functions we are importing, so we have included this as in the header section, I mean as a header file. Okay. Define whatever the name of the class as per your wish. I have defined here it as LB. LB stands for leaky bucket. It can be anything. Okay. Some of the variables are declared. OPI, bucket size, and N. Okay. These are the integer variables we have defined. And packets. See, these packets, multiple packets we are going to insert. So count value is required, right? So packets is an array of type integer with size. We have defined size as 100. There is a method included inside this class LB. So bucket input, BKT input stands for bucket input. Bucket input takes two parameters, A and B. You will come to know what is that A and what is that B. Okay, here I'll discuss about this bucket input function later. We'll go to the main function because as you are aware of, program execution is begin with the main function, right? So public class leaky is the method where it includes the main function in it. Okay. So public static void main is the declaration required. So main function to be marked as public since it can be accessible from anywhere. Static means what? Just recall the Java concept. Static means what? Without the help of the object, the program can be executed or program can be called, right? So you are creating the object of the LB class. Object creation step. So LB is the return type, right? Obj is the name of the object. Recall the object creation step in Java which you have studied in the previous semester. So LB obj equal to new LB, right? This is what the object creation step. Next, you are creating the object of the scanner class. So scanner, scanner is capital S capital, right? This is the keyword. Then class name can object name can be anything. I have used the same object name scanner, but S is small. Don't get confused. Okay. These are the statement. The second statement you have to make for the execution. Sorry. This statement is required for importing or a declaration of the scanner class object for input purpose. Next, you have to ask the user or programmer about the bucket size. Read the value and store with respect to the variable. What is the name of the variable? Bucket size is the variable where we have declared the bucket size variable inside LB class. So with the help of the object obj, dot bucket size, which holds the value whatever the input you have entered. Say scanner dot next int. This is the function which lets us to input the value and stores the value onto the corresponding variable of the object. Obj is the object of the LB class. Ask the user about the output rate. As per our previous discussion, I said you two numbers 20 and 10 right earlier. 20 was the size of the packet and 10 was the output rate. That was the consideration. Whatever it can be, right? Any value you can enter as per your choice. Enter the output rate. This is to be stored somewhere. So I have used a variable OP. This variable is declared inside LB class. So LB class object, use the same object obj dot OP, which is equal to again scanner dot next int. Use the same function. Next is enter the number of packets, right? Bucket size is entered. Now output rate is entered. Your job is to enter how many packets you want to send, right? You are talking about the transportation. How many packets you want to send? That value, count value is required. Read that count as n. Very simple to understand. So bucket size, it will be having one size, say the capacity, maybe 50 packets or 100 packets of so and so size, whatever it can be, right? Output rate is the size of the hole. What is its capacity? How many units of data it can or packets it can send per second? That is what defined earlier. Now how many packets you want to send? That is what n value, count value. Enter the number of packets. So obj.n equal to scanner dot next int. Okay. Next system.out.println, enter the size of, obviously. Next step is, suppose you want to transfer or 3 packets. You have to tell the size of each packet. What is the size of each packet? It can be, as I told you earlier, unit can be bytes or my MB or whatever. Right? Units are not important now. For us, this data, the numbers are important. What is the capacity or size of first packet, second packet, and third packet? You have to tell manually. So first packet, second packet, and third packet, 3 times you have to ask the user to send the since you have the user has told user has decided to transfer 3 packets. So size of each packet, it's his job or her job to tell the system what is the size of each packet. Getting no? So thrice times this packet value data should be uh, provided as input. Hence we are using a loop here. Very simple. Int k is 0, k less than obj, k plus plus, right? Obj dot packets of k, which is equal to scanner dot next int. Obj dot packets of k. Now k is an array. Sorry, packets is an array. As you are aware of, packets is an array from LB class. Say its size is 100. Int packets equal to new int of 100, right? Getting no? Maximum capacity 100 packets you can send as per this program. You can increase the value of the array at any time. So I have taken the example of 3 packets. 3 is obviously less than 100, you are aware of. So k is less than obj.n, right? Then k plus plus. So obj dot packets of k equal to scanner dot next int. The first insert first value whatever you have entered, say 5 is the size, 5 is the size, that will be stored at packets of 0 since value of k is 0. Then k is updated to 1, k less than now value of k is 1 less than obj.n. Obj.n is 3, right? Because 3 packets you want to send, count value is 3. So next is 1 less than 3, let it be 10. Okay, 10 is stored at packets of 1. Getting no? Very simple thing. Next, for each packet, okay, you have to provide the details of transport, in the sense whether the packet has reached successfully or there is a congestion, that is to be identified. So for use the same loop, for j is 0, a different variable I have taken. J, since k is already used, so j is 0, j less than obj dot n, j plus plus. Again, since for it is for 3 packets, so thrice the statement will be printed. Each and every packet id will be printed, followed by whether it has sent successfully or not, right? Packet number, that is packet id. Packet id starts from j, value of j, so packet 0, first packet. Its size, obviously obj dot packets will give you the size. Next, you have to make a call for the function, bucket input function, bucket input obj dot packets of j, comma obj dot op. Since it takes two variables, what are the two variables? So two variables are a and b formally. So formally they are a and b. So in place of a, what you are passing, obj dot packets of j. In place of b, the output rate. Very simple thing. In place of a, your packet size, okay, packet size. In place of b, what you are passing, output rate. Getting the packet size and output rate will be passed. Now let us assume, as I told you earlier, I want to transfer 3 packets. Let me take a blank page. So what are the 3 packets? This is the array packets of 0, 1 and 2. These are the value of j. Okay, 3 packets are there. Say the size of each packet we have entered as 5, 10 and 20. Getting no? So the first packet, for the first packet, the size I have entered, say output rate I have entered is earlier. Assume output rate I have entered as 10. Output rate is 10. Now, first iteration of the loop, obj dot bucket input function, you are making call obj dot packets of j. Packets of j, value of j is 0. So packets of j, what is the value? See here, packets of j, initial value is 5. So the first parameter is 5. What is the second parameter? Second parameter is constant value, that is obj dot op. Op is the output rate. What is the output rate I have entered? Say I have entered the output rate as 10. Now make a function call. What is the function call? Bucket input is the function. Make a call for the function bucket input with two parameters. What is the first parameter? Formal in it is read as a, second as b. So 5 and 10. A is size, b is rate. Okay. Now what is the bucket size? Assume the bucket size, output rate I told output rate I have entered is 20. Say, okay, output rate I have entered is 20. Now sorry, output rate I have entered as 10. Okay. Now a is compared with, what is the value of a? A is 5. It is compared with bucket size. Bucket size is entered by you. Say, assume bucket size you have entered as, this was not considered earlier. I mean, below I did not write, consider this bucket. Sorry. Let the bucket size be I will be taking different value. Later I will consider that overflow scenario. Okay, let the bucket size will is 30. Now A is compared with bucket size. What is the value of A? 30 is compared with bucket size. What is the bucket size? Bucket size is A is 5, bucket size is 30. 5 greater than 30, is it true? No, bucket overflow will not be executed. Now, while A is greater than B, A is greater than B. What is A? You are aware of. A is 5, B is 10. So, A is greater than B also false. 5 is greater than B, 10 is also false. So, A is greater than 0. This is true. So, last so and so bytes sent will. What is the last so and so value of A will be printed? Last 5 bytes sent, leaky bucket successful. This is done for the first packet. Then loop will be updated, so it will go for the next packet. What is the next packet you have entered? Next packet with size 10, right? Again, in place of output rate is constant, so 5 instead of 5 10. Now what is the new value you are sending? 10 10 you are sending. 10 10 you are sending, right? Again, make a call for the same function. 10 is greater than 30, obviously false. Bucket size is 30, right? 10 is greater than 30, false. Bucket overflows will not be printed, so 10 is greater than 10. Now this time A is greater than B. Both the place we have 10 and 10. 10 and 10. This is false, right? A is greater than B also false. So nothing will be executed from while loop. What will happen? Last 10 bytes sent, leaky bucket successful will be printed. That is for the second packet. Third packet is remaining. What is the third packet? Its size is 20. Third bucket size is 20. Okay. In place of now check carefully. In place of A we have 20. B is constant, that is 10. So in place of A we have 20. So 20. B is 10. Now 20 greater than bucket size 30. Bucket size is 30. This we have fixed to 30. Right? Getting no? Bucket size is 30. 20 is greater than 30 is false. So bucket overflow will not be done. Now while A is greater than B, obviously bucket size, now packet size is 20, output rate is 10, 20 greater than 20 is true. What will happen? So it will divide, since all the 20 bytes cannot be sent, since the output rate is fixed to 10 bytes. So 20 should be divided, right? That's it. How? Say how many bytes are first B bytes are outputted. We have to consider the transfer of first B bytes. What is that? B is value of B is what? Since the capacity or data rate is defined by term B, right? Data rate or capacity is defined by the term B. 10, it is fixed to 10. So first 10 bytes are sent. How many remaining? You compute. Compute the new value of A. What is new value of A? A equal to A minus B. A equal to A minus B. What is A? A minus A is 20 minus what is B? 10. So how many remaining? That is A. 10 is remaining. This is what computed with the help of the formula. That's it. You need to remember only one line in this formula. A equal to A minus B or A minus equal to B. That's it. Right? So you are inside the while loop. Now while A greater than B, 10 greater than new value of A is 10. 10 greater than 10 is false. So what you are supposed to do? Check it is greater than 0. Obviously it is greater than 0. So last so many bytes, so many remaining? 10 remaining. Last 10 bytes sent. First 10 bytes are sent initially, last 10 bytes are outputted. Right? Leaky bucket successful. This is one case. Now let us see what is overflow. Now bucket size bucket size you fix as 15. Let me fix the bucket size as 15. What is the bucket size? Earlier I have considered as 30. Now case 2, I am considering bucket size as 15. Getting no? First packet, what is the size? 5. Obviously, packet size is lesser than a bucket size. No, and packet size is less than uh, data rate of initial 5 bytes will be sent. So second packet I want to send, the size is 10. Same input I am going to provide 5, 10 and 20. Okay, first two cases, in case number 1 5, there is no problem because 5 is less than 15, right? 5 is the packet size, 15 is the bucket size. Then second case number 2, uh, 10 10 is the packet size, bucket size is 15 bytes, so 10 bytes can be inserted inside 15 bytes, no issue. Output rate is also 10 bytes, so 10 bytes will be immediately sent. The last packet I have inserted is what? 20 bytes. What is the capacity of the bucket I have defined? Capacity of the bucket is only how much? Only 15 bytes. So bucket size should be greater than the packet size. Here what I did is packet size itself is larger compared to the bucket size. Obviously it cannot be inserted. No, practically you think it cannot be inserted. Overflow statement should be displayed for this, right? So at for case number 3, what will happen here? A and B, in place of A you are receiving 20, B you are receiving 10, right? So what is the bucket size defined? New value of bucket defined bucket size is 15, right? Value of A is 20. 20 is greater than 15. Condition is true. What is the output? You are going to print bucket overflows and it terminates. Nothing else, right? You can verify the outputs here. This has got the outputs also. Okay. I'll be sharing the manual. Oh, so sorry, I have already shared the manual on the group. Please go through the manual. Hope it is visible. Otherwise, you check the PDF of the manual, you will come to know. Okay. Please pause the video, write down the program, maintain separate notebook for it, for the programming part. Okay, or you can make the part division in the same notebook where part A is the simulation, part B is the programming part. Okay. One thing you need to, main things you need to remember is the bucket which has got certain capacity, so the packet size itself is larger compared to the bucket size, then you have to say overflow. Okay, you have to say uh, bucket overflows. Okay. Otherwise there is a tab just below the bucket, there is a tab. This tab, with the help of this tab we can send the data in a constant rate. That is what data rate is. If the size of the packet is slightly larger than the data rate you have fixed, then divide the packet and send. Very simple thing. But remember, the packet size should be smaller than the bucket size. If the packet size itself is exceeds the size of the or capacity of the bucket, you have to say bucket overflows. That's it. Very simple thing, very easy to remember. Okay, please go through the manual, write down the program carefully, write the output also. Okay, if you have any doubt, please feel free to ask. Let us continue our discussion in the next session. Thanks for watching. See you in my next video.